Okay, good morning, students. So, we are going to start today the new model that is model number 3. Okay, the new model we are going to start now. So far, we have covered model number 1, model number 2, model number 4, as well as the model number 5. Okay, now this is the last model of your syllabus, that is a model number 3. Okay, so in this model number 3, what you are going to study and what are the things are there in the concepts of the model number 3 that we are going to discuss today now. Okay, so the solidification and the non-ferrous foundry practices. Okay, so what do you mean by the solidification? So the solidifications process which is occur in the casting phenomena, okay, during the foundry, when you do the foundry castings, okay, at that moments how the solidification is carried out and what are the methods of the solidifications, okay, that you are going to study. Now let us see the titles which are contained in this module or the concepts. The introduction of and solidifications that you are going to study, I will tell you the introduction. The nucleation nothing but the initial stage of the solidification where the molecule starts to convert into an crystals. Now in the next, the types of nucleation you are going to study. Okay, so in that, the homogeneous and heterogeneous nucleations you are going to study. The solidifications variables, so what are the variables to be controlled during the solidifications that you are going to study. The types of compositions of the casting alloy, thermal properties of both the alloys and the molding materials, and the cooling rate also. So this is one of the solidification variables that you have to keep in a control. Then next, the mold thickness and the shape. Okay, then the chills getting and the other casting design factors. So these are the variables which are to be kept into an parameters or within the controls during the solidification. As well as last one is an pouring temperature of the molten metals. So these are some of the variables you are going to study in these modules regarding the solidifications. Now there is a directional solidifications and it needs of the casting. What do you mean by the directional solidifications? So see, when the liquid metal which is in a hot condition, hot liquid form metal, is has to be converted into a solid metal. For that reason the solidification process is been done. So there is some methods or some procedure is there in which the hot air or the hot gases which are being released out by that liquid metal, so that the temperature releasing or the heat releasing is coming out, by which the metal that which can be become and solidified. Okay, so this is how the solidification is been carried out. Now next we see the directional solidification. What do you mean by directional solidification? For releasing such types of heat and the temperature or the hot gases of particular direction is been given, by which the way the gases are been released out, or the you can tell that the heat is been released out. Once the heat start to release out, the temperature of the molten metal decreases over there, and which allows that molten metal to convert to from liquid to solid position. Okay, this we are going to study over here. Now there is some methods, factors controlling in the directional solidification that you are going to study. The some factors and the methods are the proper design and the position of the gate and the risers. Okay, use the insulation pad and sleeves for the risers, okay, that you are going to study. So these are the some methods. The use of chills in the molds. Now next, the use of an blind risers, okay, use of an exothermic riser compounds. So these are the some of the methods and the factors which are used for controlling the directional solidification. So we'll go in the deep. I will tell you what are there and how this has been done. Now another important concept is decasification in the liquid metal. So see, what do you mean by the decasification? When the metal is been melted in the furnace, okay, at that moment what is happening, some atmospheric gases are being trapped in the molten metal, or you can say inserted in the molten metal, or at that moment also. And another time moment where the gas are being entrapped in the molten metal, when the molten metal is carried from the furnace to the pouring point means where the molding box are kept, that is called as a pouring point. From the furnace to the molten mold cavity, mold box are there where the molten metal is to be poured. During this period, or during the carrying of this molten metal in the crucible, whatever the atmospheric air is that is been entrapped in the molten metal, or you can say hide in the molten metal, that gases are to be removed out before pouring that molten metal in the molding box. Otherwise the gases with the molten metal enters in the mold cavity. When it's the molten metal gets solidified, that gas remains inside and make an hole or a hollow hole within the casting, which is called as an defect. That the such type of defect is called as an porosity defects. Okay, so to avoid from such types of defects, the gases has to be removed. Or for removing of the such gases, there are different types of methods are being used for removing such types of gases. Okay, that also we are going to study the sources of gases in a liquid metal and its prevention. So how the gases enters in the liquid metal and how to prevent that one. The furnace atmosphere, just now I told you that where the furnace is there, where the metal is to be kept for the melting at a high temperature, it is exposed to the atmosphere, means it is open to the atmosphere. Okay, at that moment the atmospheric air which is surrounded towards the furnace has been trapped over there. Now second one is on furnace charge. Furnace charge means what? If there is an gas furnace, you are using a gas furnace for the charging purpose. Okay, at that moment whatever the gas is been released over there during the operation of the melting process, the gas may be enters, same gas may be enters in the molten metal. Then third one is an ladles. Okay, whatever the ladles during the carrying, okay, the crucible cup during the carrying, the gas has been absorbed, or the when the gas is being poured into the crucible cup or the ladle, so the wall or the chemical composition due to which the gas has been entrapped in the molten metal. Now next one is an furnace to the ladle or ladle to the mold. So see, just now I have told, from the furnace to the ladle the carrying is there. At that moment also the gas may be enters. From the ladle to the mold pouring point, that is a molding box is kept where the molten metal is to be poured. Between that distance also the gas may be inserted. Okay, so these are the some of the sources how the gas is been entrapped. So we'll see the prevention between in the next classes, how the prevention is to be done. Okay, in the molds also the gas has been absorbed by the molten metal. Okay, that also we are going to study. Now this gasification method. Okay, now just now so far you have heard about the how the gas are being entered and the sources are there to enter the gases in the molten metal. Now we are going to study in this concept, this gasification method, how that gases has to be removed out from that particular molten metal. Okay, so there is a method to remove out the gases from the molten methods. Okay, now the following methods are, first one is in flushing. Okay, so in the flushing what they do, they flush out the gas. So molten method to remove it, in the details we will study in the next class how the detail degasification method is there. Okay, that you are going to study over here. Now next is an vacuum gassing system. Now you can see over here in the vacuum gassing system there is a crucible cup is there in which the molten metals are being, molten metal is there. Okay, the external air blow is been given out and small black dots are there, that's are nothing but the gas which are coming out of that molten metal. Okay, so this is how the disgasification done is in vacuum. In the vacuum there are some different methods are there, static methods of disgasification. Now you can see in the diagram, so we'll go in the details what are the static gasification. Okay, induction degasification is there, then the steam dropped degasification is there, fractional degasification is there. Okay, now next is an fettling and cleaning of the casting. What do you mean by the fettling and cleaning of the casting? So see, the fettling and the cleaning of the casting is nothing but it is also one of the operational procedure. Okay, after the casting is been removed out from the foundry, it directly goes for the fettling shop. So what happens in the fettling shop? Okay, so you can see over here removal of an sand and other impurities. Second one, removal of an excess material, and third one is an finishing of the casting. So see, after the casting which is removed out from that sand, so whatever the dust particles are attached to that, that are been cleaned. Then the second one is a removal of an excess material. So I will tell you which are the excess materials are there. Okay, then the casting finishing by the help of an hand handle. So we will go in details regarding this also. Now next are the casting defects. So there are so many defects are the casting defects that we are going to study, how they does they causes and what are the remedies for that one, and how you are going to overcome to this defects. Okay, so first one is in shrinkage defects, second one porosity defects, misrun defect, penetration defects, okay, mold ship defects, then this is a cold shut defects, hot tears defects. So these are the some of the defects we are going to study in these defects, the causes and the remedies regarding to these defects, how to clean the defects and clear the defects. Okay, now the advantage and the limitations of the casting process, overall casting process, that you are going to study over here in this model. Now this is the half portion of an casting process is been finished over here of the model number 3. Now another half is an introduction to the non-ferrous for the practice. So the non-ferrous materials can be also done by the casting process components. If you want to make a prepare any of the components, so the non-ferrous materials can be also used by the foundry method for the or the casting method for making a components. Okay, so in this non-ferrous method, the aluminum is the most common material which has been used for removing the casting products. Okay, so the advantages and the limitations of the aluminum castings we are going to study in this concepts. Okay, now next, the melting of an aluminum alloys, okay, that you are going to study. Okay, now over here there are the furnace, lift out crucible furnace is there. Okay, so so far in the previous modules, okay, that is in module number 2, you have studied regarding the melting furnaces. So in that, the induction furnace, okay, and direct arc and the arc furnace, electrical furnace, or the gas feed furnace, these types of furnace are can be used for the non-ferrous melting, for the non-ferrous metal meltings. Okay, now lift out type of crucible furnace it is. Now you can see in this furnace there is an, it above the ground level, the fire is mostly the fuel is being supplied over here. At the center the crucible is kept, below there is a bottom, and top there is a cover. So whatever the small furnace is been added. So see, these types of the non-ferrous metal furnaces are capacity having very less compared to the non, ferrous metal. So it is 1 kg, 2 kg, up to maximum 1 ton the non-ferrous metal can be melt. Okay, so the small production or the small quantity the non-ferrous metals are been made held. Now the hardness used in the aluminum casting, hardness used in the aluminum casting. So since the aluminum products are very soft and the ductiles, the property of an aluminum is very soft. For increasing the strength of the aluminum components, the hardness is to be done so that the hardening property can be increased for the where you remove the aluminum castings. That also we are going to study over here now. Okay, now we'll go proceed further. This is a master alloy hardening in the solution. Okay, at power liquid aluminum temperature, thus minimizing the dust formation for the suitable hydrogen. Hello, the draws. Hello, can you hear me? It is audible. Hello. Okay. Uh, Due to network, I was okay. The drossing is a mass of an solid impurities. Okay, that floating on the surfaces first surfaces that has to be removed out. Okay, because of that the solidification product can be done which has been not done properly. So regarding the drossing we will go in deep. Okay, in the next class the oxidized separations and the removal that you are going to study. Then next is an gas absorption in an aluminum casting. So how does the glass have been absorbed and how that the gas has to be removed out, that you are going to study it in this module. Okay, this concepts. Now next, what is a grain refinement in the aluminum alloys. Okay, so the grain size and the fine numbers has to be maintained after the solidification. When the aluminum starts to solidify, that you are going to study over here, and there are some methods, okay, to control the grain refines in the aluminum, the thermal method, chemical and the mechanical method, that you are also going to study in this module. Now the pouring temperature, how much temperature is to be maintained and what conditions to be maintained for the non-ferrous metal. Okay, now one more thing is that there is a concept of an stirring casting. Okay, so say stair casting is one of the important concept is there that you are going to study over here in the stair casting. See over here in the diagram, the stirrer is there at the middle. So during the melting of the furnace, the stirrer is there to stir the molten non-ferrous metal so that the equal temperature can be distributed over there with the gases it has been used. Okay, in the details, the constructions and the operations regarding this one, we are going to study this one. So for the model number 3, this is what the concepts you are going to study over here. So join the classes regularly. So this is the last module of your MCW syllabus that I have to cover now. Okay, now let us start with the first concept of this model number 1, introduction to the solidification. Okay, so see, introduction to the solidification. What is the solidification? What do you mean by the solidification? It is a simple example of an ice. Okay, when you put, everybody having a refrigerator or you have seen the refrigerator, how does the deep freezer, okay, not complete refrigerator, so there is a deep freezer is there where the below minus degree temperature is to be maintained in the refrigerator where the ice is be done. Okay, what you are going to do, what is the procedure for making an ice? Any required shape or the design or different shape, the ice trays are there in which you are putting in water. Okay, normal water, and that water is been placed in that freezer, and the freezer is been closed, and okay, and allow that water to freeze below minus 0 degree Celsius. As the temperature goes below the minus degree Celsius, the water temperature starts to reduce over there. Okay, as the water temperature start to reduce, the molecules in the water starts to freeze and convert from liquid to solid. The same procedure is been applied in the molten metal when it is been poured into the mold cavity to get the solid casting product. Okay, so the solidification is the process by which the substance undergoes a phase formation. Phase formation means what? Different phases are there: liquid phase, semi liquid phase, semi solid phase, then the solid phase. Okay, so undergoes the phase formation from liquid states to solid states, from liquid to solid. Okay, the water converting into an ice is a simple example of the solidification process. Okay, in a casting process, as the molten liquid is poured into the mold cavity, it is been to cool. When the temperature drops below the freezing point, okay, not over here in the freezing point means melting point, okay, of an material, the solidification starts. It should be noted that the change from the liquid to a solid does not occur at once. Instead proceeds through a series of an events. So see, from the liquid to solid, when the metal is converting from the liquid to solid, it does not convert directly to the solid. At the middle there are some of the different phases as occurs. Okay, different stages are there. Okay, at that moment, okay, different stages means what? The crystal generation movements are occurring. Okay, where the crystals are generated, as on it goes on solidification, it starts to generate its own molecular structure within the liquid. Okay, so that molecular structure depends on the composite material. Composite means what? Different types of materials you are going to melt in a single crucible. Okay, when it melts, it's convert into a single liquids. Okay, once it converts into a single liquids, so each and every materials having its own solidification time, it starts to generates the nuclei or the crystal according to a own solidification time. So what is the nuclei and what are the generation of the crystal, we will study over here in the next concept. Okay, in the next sudden one. Has no all the metal shrink during, okay, the changes of the phase of a liquid to solid. So in the what everybody knows what is the shrinkage. From in the last all the modules I have told regarding the shrinkage, what is the shrinkage and how does the shrinkage occurs. Okay, so the shrinkage phase from the liquid to solid. Okay, the shrinkage during the changes of a phase from liquid to solid occurs. Okay, that is one of the major phenomena occurs during the solidification, that has to be controlled during the solidification. Has such a proper understanding of a solidification mechanism, so how the solidification should be controlled, that is to be is an essential to prevent the defects during the shrinkage of the metal. Okay, so the further during solidification, the atoms of the materials are rearranged, leading to change the microstructure of the materials. Okay, that also we are going to study here, and hence the property of the material can be alternate at the desired shape. Okay, so see over here what they are telling: by controlling the solidification process suitably, the microstructure and hence the property of the material can be alternate at a desired. So see, whatever the property is there of the material and the microstructure can be controlled by the solidification method. So see dear students, when the metal is completely heated, okay, when it is heated, if you dip that metal into the water, that hot metal into the water suddenly, So that is called as an annealing process, sudden cooling process. When any of the material, iron particles, okay, ms material you can take, or the iron ferrous material, if you dip into the water, sudden cooling is done, sudden solidification is done, okay, the mechanical property changes. So the mechanical property of that material will adopt an hardened property, okay. If the material is ductile, if you heat and if you cooled it suddenly, so the ductile material can convert into a hard material, okay. If you allowed the metal to cool at an atmospheric temperature, that means what, it will take a solidification time 1 2 3 or 4 hours to get solidified. In spite of keeping it on the atmosphere open air to get solid, okay, if you spray a sprinkle of an water to remove the temperature sudden Yg, okay, continuously you are spraying at the side of the molding box the water to for removing the temperature. If you remove the temperature, what happened, the heat also starts to release and that molten metal starts to solidified over there, okay, or to convert into solidifications. So this is how uh, the properties is will control. If it kept to the atmosphere, it will adopt its own property. If you want some hard and brittle material, so you have to solidify it as soon as fast, okay, by cooling the molten metal. So this is how the solidification can control the properties of an metals during the solidifications, okay. So this is one of the important concepts. Now let us go for the nucleation. So what do you mean by the nucleation? So see dear students, you can see in this 3 diagrams. So before going to this diagrams, so I will tell you what is the nucleation, okay, and how the solidification process occurs, what is called as a nucleation. Nuclei and the nucleation, these are the different so the nuclei is an initial stage of the crystal and the process is called as a nucleation. So see dear students, when you put one small seed in a ground or in a earth, okay, in a ground, in a mud, if you put one small seed, any crop seed or any tree seed, if you kept over there, then after few days what happen, you can, if you put in water and the fertilizer to that seed continuously at a proportional rate, after few days what happen, the seed starts to remove its root, okay. Once it's remove its roots, on the next day it starts to remove its leaves, okay. Then afterwards the root starts to increase and the size of the leaves and the branch of that tree from seeds starts to increase. So this is what the phenomena shows, tells that the growth of the tree, how does the tree grow from a single seed to a longer branch of the trees or a huge big trees, okay. So over here the seed which is playing a role like a nuclei, okay. So what is a nuclei? When a liquid cools below a freezing point, okay, that is a melting point. When liquid starts to cool, the initial stage of the cooling, dear students, keep in your mind, when the molten metal starts to cool, the first stage of the solidification, first stage, okay, it starts to solidifies, the atoms of a liquid metal binds to bond together forming a very small crystal called an nuclei. So see, so whatever the solid product or the metal you are going to melt, okay, whatever the solid product which you are going to melt over there, okay, that's having its own nuclei, sorry, that's having its own microstructure, okay. Once it's convert into a liquid, it totally dissolves and changed its microstructure, okay, converts into a liquid form, okay. Now from liquid to, once again when it's come to solidification, it starts to generate a new microstructure and the new format of the structure, okay. So in that microstructure, whatever the alloys and the different composite materials you are added, that are also been adds in that one. Okay, that also combines with the main core metal or the main metal which you are adding. For example, if you are putting in gunmetal, in that gunmetal some of the copper alloys, some percentage, less percentage if you are adding. So all these three materials if are melted, so what the main huge material is that a gun material on a large percentage you are melting over there, that also dissolve and change its own microstructure completely, it converts into a liquid. Okay, so this liquid, another aluminum or the copper, whatever the alloys you are adding over there to get and desired property, that also melts with that one. Okay, a fusion is occur. Fusion means what? A mixing of a liquid, all liquids are mixed with each other. Okay, so then after when it starts to solidify, the each of the atoms of the different alloys touch with each other and create a small seed of a generation of a microstructure, a small seed or the initial stage of a crystal. Okay, that is called as a nuclei. Keep in your mind. Okay, a very small size of a crystal or a initial stage of the microcrystal, which is to be called as a nuclei. This process takes place as severe located as shown in figure. Now you can see over here there is a small spots are there, that is called as an nuclei. Okay, the formation of a new crystal, the formation of a new crystal has a nucleation. So this phenomena of the formation of a new crystal is called nucleation. Okay, the point where occurs the nucleation point is called, the point where the nuclei is generated, that is called as a nucleation point. Has the solidification process, the crystal increase in the size of a progressive additions of an methods. Okay, grow until by the image upon the adjacent growing crystal. So see, now next in the diagram you can see over here. So this nuclei starts to grow in a crystal form. It starts to grow in a crystal form until it come to the cross to the adjacent crystal. Adjacent crystal means what? At the side another nuclei is generated. Okay, when that both these nuclei are converting into crystal or growing into in a crystal form, when they touch to each other, the movement of the crystal is been stopped over there. Okay, now next, the crystal goes continuously in the three dimensional. Okay, three dimensional means what? Anywhere in the x, y, z, in any direction, top, bottoms, left, right side. Okay, in that manners it has been growing on, forming a tree like appearance. How does the tree grows? At that manner it has been, the crystal has been grown left, right and an upward direction. Okay, so it is known as a dendritic growth. So it is going in a zigzag manner. So it is growing in a zigzag manner. You can see over here it is growing in a zigzag manner in a tree, like just like a tree shape. So this is called as an dendritic growth of a crystal. Okay, the dendritic growth in a different direction in each crystal. Finally, when one dendritic impinges upon the adjacent growing dendritic, the grain formation is been started. Okay, the crystal growth case in all the variables liquid metal has been solidified. Okay, now the after that crystal, the grain is been start over here when this dendritic growth is been growing, when that dendritic growth or the crystal, okay, which are growing in a dendritic manner, touches to each other, then the crystal movements is been stopped. It starts to convert into an grain size. Grain size means what? A grain shape it is been going to convert over there. Okay, the crystal stops over there growing when it touches to each other. Okay, so this is what the nucleation is there. So how the nucleation is being generated and what is the nucleation and which method the nucleation get converted into crystal. Okay, that is a dendritic manner. Now what are the types of nucleation? So see, there are the two nucleation methods are there. Okay, generation of the nucleation, one is an homogeneous and another one is an heterogeneous. So what do you mean by the homogeneous? When the nuclei takes place in a liquid metal without the help of any impurities, that is known as an homogeneous nucleation or self nucleation. The nucleation based on this mechanism takes place in the pure metal only. So see, the nucleation which is generated in the liquid metal, okay, without help of any other source, okay, it has generated by its own, okay. So that nucleation seeds or the initial stage of the crystal which is generated without having the help of any other particles in the molten metals are called as an homogeneous. The nuclei generated by its own self is called as an homogeneous. Now what do you mean by the heterogeneous nucleation? On other hand, when the nuclei takes place with the help of impurities, it is also known as an heterogeneous nucleation. Okay, impurities can be in the form of sand particles, alloys, additionals, oxidizes, or even the surface mold walls. So see, by mistake during the pouring of the molten metal, some of the sand particles has been inserted in the molten metals, okay, or the molding walls are there from where the temperature is been released are been inserted in the molten metals, okay. So these are the some of the contaminants which helps the generation of the nuclei in the molten metals for the creation of the crystals and the grain, okay. So these types of process or the phenomena of generation of the nuclei is called as an heterogeneous nucleation, okay. So dear students, it is a very important concept, homogeneous and the heterogeneous. As per the exam point of view, they may ask the difference between the homogeneous and heterogeneous. For the much more details, if you want to study regarding the homogeneous, heterogeneous, please refer for the module number 3, the OP Khanna textbook. It is a very nice textbook and you can have the very deep knowledge from that OP Khanna textbooks, okay. Foundry technology, the title is on foundry technology and the author is an OP Khanna, okay. Now the solidification variables, these are the variables which has to be controlled during the solidifications. The solidification process by which, so I think the time is going up now, last 1 minute is there, okay. Within the 1 minute we have to wind up this module, okay. So in the next classes we will go with the solidification of the variables and further concepts is, okay. So this is the last module, don't miss this module classes, okay. Study regularly, okay. So go on. So see, the college may be start as soon as possible if the all the crises have been removed out of the COVID-19. The college may be start. So see, whenever the college may starts, you are directly going for the examinations, okay. They may be the within 1 or 2 days the internal may be taken for all the 5 modules. Cow.